Review of inverse functions. What is an inverse function? Well, one way to look at it is that an inverse function switches all the inputs and outputs of the original function. For example, let's say I had the function that takes a number and doubles it. It multiplies it by 2. So if I stick in 0, I'll get 0. 1 times 2 is 2, and then 4 and 6. The input was some sort of number. The output, you might say, was the double. Well, if I then go on to form the inverse function, everything gets switched around the other way. What was an output is now an input, and vice versa. The inputs are here in the output column. The x's and y's have switched places. You could even say now the double is going in, and that original number is coming out. In the original function, we stuck in 3, we got out 6. In the inverse function, everything is switched. We stick in 6, we get out 3. Another way you can look at it is this. An inverse function reverses the process of the original function. Using our same example, the original function could be written f of x equals 2x. This is the function where if you stick in a number, it will multiply that number by 2. It will double it. Well, what would be the equation of the inverse function? We write that f inverse of x. Notice the little -1. It's not an exponent. It's just notation. It's read inverse. F inverse of x. So what do I fill in here for the equation? Well, it's just going to be the reverse of doubling something. How would you go backwards? You would cut it in half. Half of 2 is 1, half of 4 is 2, etc. The inverse function would simply be f inverse x equals 1/2 x. The original function doubles, the inverse function cuts in half. It's important to point out that not all functions have inverse functions. For example, take a look at this simple function f of x equals x squared. I'll fill in some x values here. Our job in the y column would be to square the x value, in other words, to multiply it by itself. -2 times -2 is 4. I'll get 1, 0, 1. 2 times 2 is 4. So I've filled out the table. It's a great function. Each x is paired with exactly one y. But look what happens if I try to form the inverse. I would have to switch the inputs and the outputs, and that leads to a problem in this particular example. The problem is this table is not a function. You can't have 4 going to -2 here and going to 2 here. That violates the definition of a function. Every input can only be matched with one output. So this is not a function, which means f of x equals x squared does not have an inverse function. Could we have predicted this in some way? Absolutely. If you spot repeated outputs in the original function, which is not a problem, that will lead to repeated inputs in the inverse, which means the inverse will not be a function. Well, that leads us to the horizontal line test, which is a quick way to determine whether or not a function has an inverse. We can use this same example. You might remember that the graph of f of x equals x squared is a parabola. You could plot the points to verify that. Well, the horizontal line test goes like this. If you can draw a horizontal line through the graph and it crosses at more than one spot, then that function will not have an inverse function. We say this graph fails the horizontal line test. Why does this work? Well, because if a horizontal line hits the graph twice, it's an indication that that particular y value is repeated. And having repeated y values, as we've seen, causes the problem. Thanks for watching.